Let's move on to Albert. So we are going to keep going back between the encoder part of a transformer and the decoder part of a transformer, because we want to see both aspects. Some of these papers are follow-ups on BERT. Some of them are going to be follow-ups on GPT and predicting the next word task. One of them is denoising. The other one is in a time series fashion, predict the next word. Let's do Albert. This is an assignment for you to watch that video. For Albert, you're going to use sentence piece as your tokenizer. That's why you're going to be able to get around with 32,000 for your vocabulary size. You're going to have your embeddings. You're going to have your embedding size. You're going to have the number of layers, your hidden size. Usually the feed-forward portion of a transformer architecture is inverted bottleneck. You go from low dimension to high dimension and then back to low dimension. And then you have multiple heads. What are the changes that Albert does? It notices that if you go from your vocabulary size to the vocabulary embedding size using a single matrix, you're going to end up with a lot of parameters. And that's what BERT was doing. You can reduce that by going to a lower dimension and then coming from lower dimension to the higher dimension. And this way you're going to save parameters. We had this next sentence prediction task, and you were asking me questions about what is the job of that. Next sentence prediction for BERT is a simple task. Are these two sentences coming from the same document or from different documents on your corpus? So that's very easy. You can actually look at the words that are in common and say, probably these are from different documents. So that's an easy task. We can make that task a little bit harder. They're going to be from the same document. You just switch their role. Sentence A, sentence B is going to turn into sentence B, sentence A. That's the way that you're going to truncate them. And then you're going to say that are these consecutive or are they not? Are they swapped? That's a harder task to solve for. And then later on, we're going to see that this next sentence prediction is actually not necessary. As soon as you make your model larger, train it on more data, you can actually get rid of that. We don't really need it. And then you're going to, with these two tricks, especially this first one, you're going to be able to lower the number of parameters. And as soon as you have lowered your number of parameters, you have a smaller model. If you have a smaller model now, you can increase your hidden size. You can make your neural network deeper to end up with the same size as you had initially with BERT, and then you're going to be the state of the art. So whenever you take a step towards making a model smaller, you're aiming two targets with only one shot. Not only you can make your model smaller, but at the same time, you can be the state of the art if you increase the size to the original size that you started with. And if you want to study next sentence prediction versus sentence order prediction task, you can study them and see that, yes, they're actually useful. The other one is you can actually add more data. For BERT, you were using Wikipedia plus book corpus. If you keep adding more and more data to it, we said these models have the capacity. They have not yet saturated, and they are not going to be able to overfit. They're going to like more and more data. If you give them more data, you're going to increase the performance. One other thing that this paper notices is when it comes to BERT type of architectures, you don't actually need dropout. You can get rid of it, and that's going to give you better performance. I think I'm going to stop here. For those of you who have questions about Albert, I'll be around. And for those of you who want to leave, you can leave. And don't forget that this is an assignment to watch that video.